Hi everyone, we want to take a look at remainder theorem and factor theorem today. Okay, so remainder theorem, if f of x is divided by a factor x minus k, then r is the remainder of f of k if r is equal to f of k, in other words. Okay, so let's try this out. Let's have a little example here. Determine the remainder if we have a little function here, f of x equals 3x squared plus 7x minus 20. Okay, so first example. Let's say, let's go back to black. Determine the remainder if f of x is divided by x minus 2. Okay, so let's say I have 3x squared plus 7x minus 20 is divided by x minus 2. Okay, so to find the remainder, we could do long division, or we could do synthetic division, okay, or we could think about, all right, what would be the potential 0 if I had a factor x minus 2? Okay, well, that would be 2. So I'm going to have a k value of 2. So then I'm going to calculate f of 2. So I would do 3 times 2 squared plus 7 times 2 minus 20. Okay, so 4 times 3, we'd have 12 plus 14 minus 20. So 26 minus 20 is 6. So f of 2 equals 6, so that we would say 6 is our remainder. If I did long division or synthetic division, I better get the same thing. All right, let's have another example. Okay, so suppose I want to take our f of x polynomial and divide it by x plus 1. Okay, just for something different. And I'm just playing with the pens just for something to do. Okay, so if I think about if it's x plus 1 I'm dividing by, what would be the potential 0? Well, negative 1. So if we do the same thing, we want to do an f of negative 1 and see what we get. All right, so f of negative 1, 3 times negative 1 squared, 7 times negative 1, minus 20. Okay, so do a little arithmetic. Negative 1 squared is just 1, so 3, negative 7 plus negative 20. I get negative 24. So f of negative 1 equals negative 24. That's your remainder. Okay, and again, same answer I would get if I did long division or synthetic division. Okay, all doing the same thing, just a different way. All right, let's throw one more in. Let's say I have my f of x, again, divided by x plus 4. Okay, so if we're thinking about this one, what would be the potential 0 here for the k value? K would be negative 4. So we need to do f of negative 4 and see what we get. Okay, so f of negative 4, whoops, excuse me there. Get rid of that. Try again. F of negative 4 is going to be 3 negative 4 squared plus 7 times negative 4 minus 20. All right, so 16 times 3, so 48, negative 28, negative 20. Oh, hey, how about that one? That's going to come out to be 0. Okay, so this time f of negative 4 is 0. So this is like winner, winner, chicken dinner. What do we know now? Woohoo! Winner, winner. All right, so we have a 0 for a remainder. So x plus 4 is a factor and x equal -4 is a 0 of our polynomial f of x. Okay, 0, we could call it x-intercept, we can call it a root, all those things. Same words, same thing, different words. All right, so that is yay. So remainder of 0 tells you all those things. Okay, so while I mentioned it, let's put on here factor theorem. Factor theorem just confirms this idea right over here. Okay, so it says a polynomial function, f of x, has a factor, x minus k, if and only if f of k equals 0. Okay, so exactly what happened. Okay, so we have a factor, x minus k, if and only if f of x equals, or f of k, sorry, equals 0. And that is exactly what happened above. Okay, hope this works out for you. And again, this was all about the remainder theorem and then how it ties right into the factor theorem. Have a great day.